Hello, let's continue our Sudoku adventure with Hotel Towers by PjoeterBliep. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. This is duality clues, so the clues outside the grid are both skyscrapers and numbered rooms. These are standard constraints, so instead of just listing all the rules of both constraints all in one, we just say it's both. So they have to fulfill both of these constraints. So as skyscrapers, the way we want to think about that is say we're standing on top of this 4 and we look down the row. So this 4 would look down this column, this 2 would look across this column, this 4 would look across the column this way. So standing on here, how many skyscrapers can we see if the digits are the height of the skyscraper? So say this was 2 and then we had a 1 somewhere over here. The fact that this is a 2, first of all, we would see the 2, but we aren't going to see the 1 because you can't see a 1-story building behind a 2-story building. And so basically what we're doing is this 4 is going to end up being the count of the number of skyscrapers we see. So I could do, for example, 2, 3, 5, 6. You can put the 6 at the end even, 4. So we do see the 2. Now the 3 is bigger than all the ones before it, so we do see the 3. 5 is bigger than all the ones before it, so we see the 5. 1 is smaller. 4 is smaller than the 5. And then the 6 is always seen because it's the tallest. So if we look at count the green cells, there are 4 green cells. So this would be one way to fulfill that 4 skyscraper. Now in addition to that, it's also a numbered room. So what we do is we want to look at the digit that's right next to the 4. Say it was a 3. Then we would count 1, 2, 3. It counts itself. 1, 2, 3. And that's where the 4 goes because the clue is a 4. If this was instead of 5, we would count 1, 2, 3, 4, 5, and the 4 would go there. Here, this places the 2. So if this was a 3, we count 1, 2, 3. We put a 2 there. All right. And so remember, there are both skyscrapers and numbered rooms. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, so numbered roomage is interesting, and we can kind of combine that with, so numbered rooms constrain this, the cell that's next to, so I'm going to start with 1 through 6 here. They constrain the cell that's next to the clue. Why do they do that? Well, a 1 is not going to be possible, because that's saying that in this cell that we just put a 1, we need to put a 4. So it's contradictory. 4 also doesn't work, so that itself doesn't work next to itself, because that says count 4 away and put the 4, which we just placed. So it would repeat in the row. So for that reason, we can never put a 1 here. Since there aren't any 1 clues, we don't have to worry about that. 1 clues are special. But we can't put any 1s there, and then we also can't match our clues. Now, skyscrapers are interesting because they restrict, as we move along, they restrict what the maximum digit can be. Similar to a thermometer, but a little bit different. So if we think about it, if I were to place a 6 here, that's kind of the obvious case. The 6 we would see, but it would hide everything behind it. Nothing's bigger than the 6. So that better be a 1 clue if we put a 6. We're not allowed to be a 6. But a 5 is going to hide everything except the 6. We will see the 6, but since the 5 hides everything else, we'd be a 2 clue. So actually we can't be a 5 or a 6 here. And so with a count of 4, we know that exactly 2 skyscrapers are hidden, which means that the highest we can go is a 3 here, which would hide both the 1 and 2. And we'd have to make sure that the 4, 5, and 6 were in order so they don't get hidden. So we can do the same thing for these 4s. We can remove 5, 6 from them. So they're all down to 2, 3. Now the 2s can't be 6s, but they could be 5s. So we got to be careful there. All right. So that makes some, so this 2, 3 pair removes 3 from here. Let's see. So let's think about the numbered rooms here. The 2 is in 4 or 5. No, it can't be in 4 because that's 2 or... No, sorry, it can be in 4. Sorry. In fact, okay, it must be here. Not that it can't be there. It must be there. So the 4 or the 5 that goes here is placing a 2. That's this cell and this cell. But this cell can't be a 2 because there's a 2, 3 pair in the row already. So if we tried to put a 2 here, we wouldn't be able to finish the 2, 3 pair. So the 2 has to go here then, and that makes this a 4, and that makes this a 3. Now the 2 puts a 4 here, the 3 puts a 4 there. This is no longer 4, and that's no longer 4, and this is our 3, which also looks at that 4. All right. So the 1 and the 2 are already hidden here, telling us that the 5 and the 6 have to go in order. So This already can't be a 5, though. In fact, this 3-5 pair tells us that this is from 1 to 6. Now 3 hides the 1 and 2. So again, the 5 and 6 have to be in order down here. This is going to put, oh, this can't put a 3 here because there's already 3 in the column. So this can't be, oh, sorry, this can't be itself. I think I removed 2 from it when I shouldn't have. I should have removed 3 from it. So I'm glad I caught that. So it puts a 3 here or here, both of which are viable. In fact, we can place this 3 because it's the only place for 3 in the column. Okay, so I think I did this whole column a little bit wrong. I think this 4 is still fine. But I did not pencil this column correctly because this is not 1 or 2, and it's also not 6, and now it's not a 4. This is not 1 or 3, and it's not a 4 because of the column, and it's never 6. But a 3 also can't be 5 because 5 would hide everything except 6, so it would be maximum 2. So this has to be a 2 then, and that puts a 3 there. All right. So 3 is in one of these two. Oof, that would have been a bad mistake. I apologize. We need 1, 5, 6 here. This is 1, 5, 6. These two aren't 2. Don't know if that matters. Okay. So we got to think about these skyscrapers a bit more, I think. Right. So we're not allowed to put a 5 or a 6 here. They need to be in order after the 4. So there's definitely a 5 and 6 over here, and this is never going to be the 5, or it would be hidden by the 6. And this is never the 6, because it would hide the 5. All right, so 5 is one of these two, 6 is one of these two. So this has to be 1. That has to be 1. That's kind of the point. And so then this is just 2, 5, 6. So again, this isn't 6, this isn't 5. So this has to be the 6. This will resolve however it wants. What's our next step here? This can't be a 5. Again, 5 has to be after the 4 because we have a 3 next to a 4. So this is 2 and this is 5. This is a 1, 5, 6. This is never 5. This is never 6. So 6 is one of these two. That means 6 is one of these two. This could be 6. We'd see the whatever this 3, 5 is, and then the 6, and we're good. In fact, if this was a 3, this would have to be a 6 in order to... Oh, this can't be 3 because there's a 4 sitting there now. So this has to be 5, which puts a 2 there. That's 1, that's 6, that's 5. All right, did we miss any other numbered rooms? I don't think so. All right, this is where the 3 goes. And then this is a 1. This pair is 2, 6. The 2 tells us that's 6, that's 2. This is a 4 to finish the box. So now we can just get our roping here. This is a 1, 3 pair. So we know that's 1, that's 3. This is 4, 5, 6. This is 2, 3, 6. This has to be 6, 5. That's 3 and 2. All right. And this is 1, 4, 5. This is the 1. All right. So now probably one of these skyscrapers fixes it. So we see the 2, 3, and 6. We're good. What's going to fix this? 5, 6. We see the 4. We don't see the 1, 2, 3. We're going to have to put the 6 here. Because if this was 5, 6, we'd see 3. So that's 6, that's 5, that's 4, that's 6, that's 5, that's 4. And we're done. All right. Nice puzzle, PjoeterBliep. I enjoyed that. It was interesting kind of bouncing back and forth between doing numbered room logic and skyscraper logic. I think I probably didn't bounce enough, but did get there. Also, really horrible problem in this left column where I thought this was a 2. But I did manage to fix it and hopefully didn't make any lucky mistakes in the process. All right. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.